Well, hello everybody. What I need to do with you today is I need to cover section R-3 with you. So what you'll need in front of you, you'll need your class notes from that day. And what section R-3 is over, guys, is it's over rational expressions. Remember, rational expressions just means written as a fraction. So as we go today, I will review with you how to add, subtract, multiply, and divide fractions. So, a rational expression is any quotients of polynomials with non-zero denominators such as these. Okay, so basically fractionals. So, where I need to go with you here, this is not on your class notes, but I need to review with you real fast some fundamental properties of working with fractions. If you have a fraction, you can multiply your numerator and your denominator by anything that you want, as long as you do it to both of them. Reason being, S over S is really 1. Now, whenever you want to add or subtract fractions, you need to make sure you have a common denominator. Once you have a common denominator, you just work with the numerators. So P over Q plus R over Q become P plus R over Q. Same with subtraction. As long as you have a common denominator, just work with your numerator. Now, when you're multiplying fractions, you multiply straight across. You just multiply straight across. And if you're dividing fractions, we can always change that up to where we're multiplying by the reciprocal. That's how we divide fractions. Now, you've done this before, just not with polynomials. You've done it with numbers. And many times you used your calculator quite a bit. Now, I'd like for you to think about 25 over 10. Just looking at that, you know that's going to reduce to 5/2. The reason that reduces to 5/2 is because 25 and 10 have a common factor. I'm going to think of 25 as 5 times 5. I'm going to think of 10 as 5 times 2. My 5's divide out, leaving me 5/2. So they have a common factor. That's the key today, is to find the common factor. Even 25a cubed, I'm going to think of that as 5 times 5 times a times a times a over 5 times 2 times a. Well, if there's some common factors, we can reduce them. So this becomes 5a squared over 2. That's going to be the concept today as we go through these. So here's your first example. 8x plus 16 all over 4. The easiest way is reduce when you can. So I'm going to think of this as 8x over 4, which is 2x, plus 16 over 4, which is 4. That's the easiest, that's the quickest way. Now, the other way to think about it, you ask yourself, when you look at 8x plus 16, can you factor anything out of that? Well, I could factor out an 8, but I could also factor out a 4, which leaves me a 2x plus 4 over 4, and then those 4's divide out. Now, once again, guys, we're looking for that common factor. Same with your number 2. I'm going to take 6x cubed over 2x squared and get 3x. I'm going to take 12x squared over 2x squared and get 6. So there, I just reduced that. Now, your number 3 is a little bit different. Let me show you what you cannot do. You cannot reduce anything right now because of this addition sign. Let me show you how you got to handle that, though. You got to write it as 2 items multiplied together. I'm going to factor out a 5, which leaves an x plus 5. I'm going to factor out a 7, which leaves an x plus 5. Now I can cancel out, I can divide out this binomial x plus 5, leaving me 5/7. Okay? So the big thing there, figure out if there's any factors. Here's your number 4. What you cannot do is this. You can't cancel anything out like that. I need to write x squared plus 7x plus 12 as something times something. So I'm going to factor it. So this becomes x plus 4 times x plus 3 over x plus 3 times x minus 1. Now, if they have a binomial in common, we can divide that out, leaving me x plus 4 over x minus 1. Okay, so you got to write it as factors, and then you can divide those out. 25x squared minus 36, that's a difference of squares, because I know each square root, and there's no number in the middle. So I'm going to factor this into 5x minus 6 times 5x plus 6 over, now 25x squared plus 60x plus 36, that's a perfect square trinomial, because the square root of the first times the square root of the last doubled is the middle. So this becomes 5x plus 6 quantity squared. Now, when I reduce this, I can cancel out one of the 5x plus 6's. So he's gone. Instead of there being 2 on the bottom, there's now 1. So my answer, 5x minus 6 over 5x plus 6. If I peek at number 6, once again, I'm going to factor this into x plus 7 and x minus 5 over x plus 7 and x plus 2. Once I divide out what they have in common, I am left with x minus 5 over x plus 2. So guys, that's how you reduce fractions. That's how you reduce the fractions. Now, let me review with you how to multiply. Remember, when you multiply, you can reduce vertically or you can reduce diagonally. So on the 3y plus 9, I'm going to factor that into 3 times y plus 3 over 6 times 18 over that 5y plus 5. I'm going to factor out a 5, which leaves a y plus 3. Now, you can reduce vertically or diagonally. So I can reduce out these x plus 3's. I can say that 6 goes into 18 3 times. So I'm now left with a 3 times a 3/5. I'm going to multiply straight across, so my ending answer in this case is 9/5. Okay. Same thing with my number 8. I'm going to factor the m squared plus 5m plus 6. I'm going to factor that into m plus 2 and m plus 3 over m plus 3 times, out of the 2m plus 6, I'm going to factor out a 2, which leaves a m plus 3 over, and then I got m squared plus 3m plus 2. I'm going to factor that into m plus 2 times m plus 1. Now I have it written as factors. Now you can divide out what you'd like. I'm going to get rid of this m minus 3. With either one of these, it doesn't matter which one, but only one. I'm going to get rid of that m plus 2. So then I'm going to be left with a 2 and an m plus 3 over m plus 1. You could distribute that 2 if you want, but you really don't need to. That's a fine answer right there. Here's my number 9. It's a division. So what I'm going to do is factor this side. Then I'm going to change this to a multiplication, and I'm going to use this reciprocal. So here's what it's going to look like. When I look at 6r minus 18, I'm going to factor out a 6, which leaves a r minus 3, over. Now, this part's going to work us a little bit. They have a 3 in common, which leaves a 3r squared plus 2r minus 8. Now I need to factor that. So I'm going to switch colors here real fast. So this is that frowny face factoring shortcut we have. 3 times -8 is -24. Two numbers that multiply to be -24 that you can make add up to be 2. Looks like 12 and, oh, that would be 10. Looks like maybe 6 and 4. Positive 6 and -4. Then I'll write this as 3r plus 6. 3r minus 4 all over 3. So here's where we are finally. That bottom factored into r plus 2 and 3r minus 4. So what I'm going to do down here is I'm going to rewrite the problem so you can now see it better. At the moment, I have 6 times r minus 3 over 3 times r plus 2 and 3r minus 4. Whew, the other side's easier at least, guys. Okay, now let's pick on the second part. I'm going to multiply by this reciprocal. So let's focus on the 12r minus 16. That's going to be on top. And I'm going to factor a 4 out of that, which leaves a 3r minus 4. This piece will be on bottom, and I'm going to factor out a 4, which leaves a r minus 3. We are now finally ready to go to work on this. Here's a r minus 3. There's an r minus 3. There's a 3r minus 4 and a 3r minus 4. These 4s divide out. 3 goes into 6 2 times. So it looks like my ending answer, 2 over r plus 2. So that's how we handle division. I only did one example there because it relates to multiplication, but that's how you handle the division. So I've hit reducing, I've hit multiplying, I've hit dividing. Now it's time to slow down just a little bit and show you how to do the addition. Now guys, whenever you add or subtract, you have to have a common denominator. My number 10 has a common denominator. So I just need to work with the numerator. So my denominator is 3x plus 1. My numerator, I'm going to take 5x minus 12 plus 8x plus 7. So it looks like I will get 13x minus 5. That's your answer. You can't factor it. You can't simplify it. Leave it alone. Now number 11, be careful there only because of the subtraction sign. My common denominator is x plus 1. But now when you work with the numerator, I've got to think of this as 3x plus 7 minus the quantity 5x minus 7. So I've got minus 5x plus 7. Make sure you distribute that. Now if we go simplify this, looks like I've got negative 2x plus 14. Now, you could factor out a negative 2 or positive 2 here, but it won't help you, so we're not going to. We're not going to. Now, I put an easy one on here, just to show you something. Notice that these are not a common denominator, so we need to get one. So, if I started counting by 12s, and you started counting by 18s, the first number that we would say in common is a 36. Now let me show you where that 36 came from. I'm going to think of 12 as 6 times 2. I'm going to think of 18 as 6 times 3. When I go get my common denominator, I have to have a 6 in it. I have to have a 2 in it. I have to have a 6 in it, but I already got it, so I'm not going to write it again. And I also have to have a 3 in it. Well, 6 times 2 times 3 happens to be 36. I'll show you here in a minute why I did that. It's a form of thinking I need you to do. Now, to bring it home, we're going to do this. 12 times something is 36. That something is 3, so I'm going to multiply this 7 by 3 and get 21. Now, 18 times something is 36. Times that 5 by a 2 and get 10. There's my final answer. So we had to get a common denominator, and along the way I had to figure out the factors of it. Here's my number 13. Got 7 over p plus 9 over 2p plus 1 over 3p. When you go to figure out your common denominator, it's got to have a p in it because of that right there. It's got to have a 2 in it. It's got to have a p, but you already have that. It's got to have a 3, and it's got to have a p in it. So my common denominator is really 6p. Which, if you really look at it, the least common multiple between a 2 and a 3 is a 6. Now, to figure out your numerator, we do this. You compare this denominator to this denominator. And then you ask yourself, what do you need to multiply by to make them the same? So I would need to multiply by 6. So I'm going to take the 7 and multiply by 6 and get 42. Now let's go to the second one. When I compare 2 times p to 6p, I need to multiply by 3. So I'm going to take the 9 times 3 and put it right there. And then when I do my 3p to 6p, I need to multiply by 2. So to this numerator of 1, I'm going to multiply by 2 and get 2. Now, when I simplify that numerator, it looks like I get 71 all over 6 times p. Here's my number 14. The trick on these, or what you got to do on these, is x plus 1 is some number. X plus 5 is some totally different number. So, my common denominator has to have the quantity x plus 1 in it, and my common denominator has to have the quantity x plus 5 in it. Now, compare this denominator to this. I am missing the x plus 5. So to the 3, I need to multiply by x plus 5. Compare this denominator, the x plus 5, to the x plus 1 times x plus 5. I'm missing the x plus 1. So to the negative 7, I'm going to multiply by x plus 1. Now, let me show you one thing that you cannot do. You cannot do. You can't cancel the x plus 5s and the x minus 1s. Because then you're just saying your answer is 3 minus 7. What I need to do now is simplify the numerator. So I'm going to distribute that 3 and get 3x plus 15 minus 7x minus 7. Combine your like terms. 3x minus 7x is negative 4x plus 8 over x plus 1 times x plus 5. Now, I might need to factor this numerator, but if I do, I'm not going to get an x plus 1 or x plus 5, so it doesn't help us any. This is your answer. Do not FOIL that out. It's not wrong, but it's not needed. Down the road, I'm going to ask you to set all of this equal to 0 to get what we call critical points, and we would rather see that than the x squared plus 6x plus 5. Now I'm going to go ahead and, I'll hit number 15 real fast. My 15, I got d and a d plus 1. My common denominator needs to have a d in it, and it also needs to have a d plus 1. Two totally different numbers. So hopefully you're starting to get the feel of this. To the 7, I'm going to multiply by d plus 1. To the positive 9, I'm going to multiply by d. Simplify your numerator. So I'm going to have 7d plus 7 plus 9d. Combine your like terms. So I'm going to have 16d plus 7 over d times d plus 1. Okay, so once again, common denominators. I'll hit 16 and maybe and 17, and I'll finish the video up. On number 16, guys, my common denominator is not x squared minus 4 times x squared plus 7x plus 10. They have something in common, so I only need it once, not twice. So here's what we got to do. I need to factor the x squared minus 4 into x plus 2 and x minus 2. It's a difference of squares. I need to factor the x plus 5 and the x plus 2. Now, when you do your common denominator, I need to have an x minus 2. I need to have an x plus 2. I need to have an x plus 5. I need to have an x plus 2, but I already got it. So I don't need to write it again. Now, compare this denominator to this. Whatever you're missing is what you will multiply by the 3. So I've got a 3 times x plus 5 plus 5 times, looks like I'm missing the x minus 2. Combine your like terms. So I've got 3x plus 15 plus 5x minus 10. Ending answer, 8x plus 5 over, this is another reason we don't want to multiply things out. That would take a little bit. So that's your answer. That is your answer. Okay. I'll go ahead and hit number 17, then I'll skip number 18. Number 17 I call the problem that keeps on giving. I will show you what I mean, of course. I need to factor everything to see if there's anything in common. So when I factor x squared plus 5x plus 4, I've got x plus 4 times x plus 1. When I factor this, I've got x minus 2 and x plus 1. And when I factor this, it looks like I've got x plus 4 and x minus 2. Now, when you play your common denominator game, I need to have an x plus 4. I need to have an x plus 1. We need an x minus 2. We need an x plus 1, but we got it. I need an x plus 4, but we got it. I need an x minus 2, but we got it. So these had quite a bit in common. The rest is just algebra. To the x minus 1, I need to multiply by whatever's missing, which is x minus 2. To the 2, I need to multiply by whatever's missing, which is the x plus 4. And to the 10, it looks like I'm missing the x plus 1. Now, we got to keep on doing some algebra here. I'm going to FOIL out the x minus 1 and x minus 2. So I've got x squared minus 3x plus 2 plus 2x plus 8 plus 10x plus 10. I'm going to simplify that, and then I'll put it over the denominator. So it looks like, guys, I've got x squared. Oh, looks like 9x plus 20. So I simplified that, and it's going to be all over x plus 4 and x plus 1 and x minus 2. And then, we're almost done. I need to see if there's anything in the numerator and denominator have in common? So I need to factor that numerator if I can. And if I do that, I've got x plus 4 times x plus 5 over x plus 4 times x plus 1 times x minus 2. I needed to do that because there's a chance they had something in common. So ending answer, x plus 5 over x plus 1 and x minus 2. Okay, so guys, that is section R-3. The assignment is on Math Excel. Good luck. If you have any problems, get in and I'll straighten you out.